On the occasion of the International Year of Basic Sciences for Sustainable Development, the Natural Sciences and Engineering Research Council of Canada and the Fonds de recherche du Québec Nature et Technologie joined forces to organize a special edition of the Science Action Video Contest.
The contest challenges members of the research community to help Canadians discover how science and engineering contribute to our understanding of the world and universe around us by documenting the people, research, and innovations that are transforming the way we live and work.
Basic science research is essential for better understanding and addressing major societal challenges, such as climate change. It also provides tools for better decision-making and the fundamental skills for training the highly qualified workforce that will find ways for a better and sustainable future.
Universities and colleges in Canada play a central role in finding ways to address and achieve sustainable development goals. This special edition of Science Action was open to graduate students who are currently working or who have worked on research funded through an NSERC or FRQNT grant.
Participants were invited to submit a 1-minute video showcasing the research. We received videos from across the country.
All video submissions highlighted the benefits of research in the fields of natural sciences and engineering by making the connection between basic sciences and the Sustainable Development Goals.
It is an honor for us to present the 6 winners of this very special edition of Science Action.
We are certain that you will enjoy these videos as much as we did, and we encourage you to share them with your families, friends, and colleagues.
Due to population growth, industrialization, and climate change, the world is expected to face water crisis. Desalination and water recycling are potential solutions. Membrane technology is the most energy-efficient technique among all water purification technologies. Membrane as the main part of this system separates salts and impurities. Advances in membrane materials are needed to improve the efficiency of water purification systems. At the University of Waterloo, Applied Nanomaterial and Clean Energy Lab, by using nanotechnology, polymer science, and computational chemistry, we developed a hybrid selective layer with a thickness of 20 nanometer, 5,000 times thinner than human hair. This novel tube membrane filters dirty water twice as fast as traditional membranes, resulting in a more efficient purification system. This research significantly contributes to the achievement of the Sustainable and Development Goals for clean water and sanitation and other cross-cutting themes.
L'échographie est une méthode d'imagerie médicale qui utilise des ultrasons, soit des sons inaudibles pour l'humain. Pour produire une image, on émet des ultrasons avec une sonde, puis on mesure la réflexion produite à la rencontre d'un obstacle, comme un visage. Toutefois, la qualité de l'image produite n'est pas toujours optimale, car elle dépend grandement de la sonde utilisée. En effet, plus notre sonde a de transducteurs pour émettre et mesurer les ultrasons, plus on pourra construire une image de qualité au détriment de la vitesse de calcul. Comme solution, le CRASH travaille à développer une sonde échographique munie d'un masque de codage, ce qui permet de déguiser la sonde en une sonde qui a plus de transducteurs. En fait, un masque de codage est une lentille à la surface très irrégulière qui déforme les ultrasons et enrichit le signal mesuré. Cela permet de réduire le nombre de transducteurs pour produire rapidement une belle image. Différentes formes de masques de codage pourraient même servir à élargir le champ de vision de la sonde, un autre effet des masques de codage qui aide la santé des humains et réduit les inégalités médicales conformément aux ODD de l'ONU.
Les forêts canadiennes vont faire face à beaucoup de problèmes. Il va y avoir plus de feux de forêt, plus de sécheresse, mais aussi des épidémies et des espèces invasives. Et tout ça risque de réduire leur fonction importante pour la planète. Il y a peut-être une chance de les aider à s'y préparer. C'est le but des recherches menées par notre équipe à l'Université du Québec à Montréal. Notre mission, c'est de regarder si on peut diversifier les forêts par l'aménagement forestier et voir si cela peut préserver leur fonction dans un futur incertain. Pour ça, on utilise des modèles informatiques de pointe pour prédire comment les forêts vont évoluer. On varie la manière dont on les gère, le climat, et on leur fait subir des catastrophes pour voir comment leur fonction perdure dans ces différents scénarios. On simule au total 4 millions d'hectares de forêts québécoises dans 240 simulations différentes. Un travail de titan réalisé par les superordinateurs canadiens accessibles aux chercheurs. Il y a de l'espoir dans la lutte contre les changements climatiques. Mais on doit préparer les forêts à un monde qui va changer.
You've probably heard of HIV, a virus that leads to a dangerous weakening of the immune system called AIDS. And while there are effective treatments against this infection, there is still no cure because HIV can lay dormant for years and cells infected with a dormant virus are not eliminated by anti-AIDS medication because they look just like healthy cells. The problem with dormant viruses is that they can wake up if treatment is interrupted and cause irreparable damage to the immune system. HIV becomes dormant through different mechanisms, one of which involves a pause in its production. I'm studying the possibility of awakening dormant HIV by overcoming this pause with the help of the hepatitis delta virus, or HDV. HDV produces a small protein that has shown very promising results in overcoming this pause in production when used on dormant like HIV in the lab. By awakening dormant HIV with this HDV protein, or a similar compound, we aim to make the healthy-looking infected cells finally be recognized as infected and eliminated by the anti-AIDS drugs.
Ammonia. Today, ammonia is one of the most important chemicals in Canada and the world because of its use in many sectors, but most of all, fertilizers, which are vital to much of the food we eat. Furthermore, ammonia is of interest as an energy storage by itself or as an energy carrier for hydrogen. This is valuable as there's a necessity for better energy storage options in a cleaner future. Ammonia is produced by combining hydrogen and nitrogen. However, the overall process generates a lot of greenhouse gases because the hydrogen is often produced using fossil fuels. To help Canada's efforts to meet the UN Sustainable Development Goal of taking urgent action to combat climate change and its impacts, my research alongside the Greener Production Group at the University of Waterloo will be about greener ammonia production. This research aims to help reduce greenhouse gas emissions which are connected to climate change. I'll be performing a cost-benefit analysis on the greener ammonia production alternatives, such as carbon capture systems and electrolysis. I will be using both engineering and economics techniques. The output of my research would be a suggestion on what Canada's ammonia production and industry should look like in the future.
Part of UN Sustainability Goal 3 aims to promote mental health and well-being. The COVID-19 pandemic and the social isolation it caused have highlighted the important role that social bonds play in our mental health. In our lab, we examine the neural pathways and mechanisms that enable us to form social bonds by studying pair bonding in zebra finches. Zebra finches are songbirds that form lifelong pair bonds which can be expressed as a preference for their mate's song. These preferences are partly mediated by dopamine neurons, which are also known to play a role in pleasure, motivation, and learning. These neurons send specific signals to higher-order sensory processing areas in the brain that are important for memory, recognition, and preference. Our lab's current research focuses on the role that dopamine neurons play in the formation of a female's preference for their mate song and the consequences if these signals are lost. Our findings will shed light on the role that dopamine plays in forming preferences in order to understand the underlying neural mechanisms that define social bonds, ensuring better mental health and promoting well-being for all ages.